Hello and welcome to this presentation, which is about the Semantic Content Hub based on knowledge graphs. I will talk about why structured and linked content is so important and how that builds the basis for a lot of knowledge services on top. Before I go into detail, I would like to address three issues that will be in focus of this presentation. So the first one is, how can we help people make better decisions? How can we prepare and structure our data to provide an infrastructure for knowledge workers, but also for end users, that they can make better decisions based on all the data available in our repositories? Then the second focus of this talk is about customer satisfaction. Customers could be end users, again, on an e-commerce portal, could be also internal employees, knowledge workers, that they need information. They would like to be satisfied by the information provided by our systems. And all that results in the third topic, which is about knowledge discovery. Not just finding a document when having typed in a search term. It's more than that. We would like to understand how things are related. What is the context around business objects we are interested in? All that is those are the typical challenges we now see in our daily work. Structured and linked content yields knowledge. So this is the mantra of this presentation. And the question is, how can we create that? How can we build an infrastructure to be able to deliver this exact structured content? So let me introduce myself based on an example of a knowledge graph, a visualization of a little knowledge graph, which gives you some context information around. You see already several business objects and entities here. I could have done the same thing by just talking and putting a linear text in front of you. But what you can see here already, a knowledge graph delivers some idea of how things are related to each other. And it's also good to remember later what those people, organizations, places, and so on, being important in a certain knowledge domain, what are they all about and how they are related to each other. So let me start. So my name is Andreas. I'm the CEO and founder of the Semantic Web company. We are the developer and vendor of the pool party Semantic suite. And one of our most important partners is RWS, a provider of a content management system called Tridion. And the company SWC, as it's also called, is located in Vienna and in Boston. So let me get back to this other part of the knowledge graph. The pool party semantic suite is based on standards, semantic web standards, which are provided by the World Wide Web Consortium, also called W3C. And those standards standardize ontologies and taxonomies, which are a typical part of knowledge graphs. So we will later see that how those knowledge graphs drive your content business. What's also interesting to see is that there's a book out there you could make use of to learn more about the semantic web standards and knowledge graphs, which is the Knowledge Graph Cookbook. I'm the author of that book. Together with my colleague Helmut Nagy, we were writing the book in 2020. In April, it was published, and yeah, you can benefit from it to learn how to use knowledge graphs in practice. Well, all that, yeah, could be extended step by step. More and more facts could be built around all the business objects in front of you. And this is exactly how our way to generate knowledge in our corporations works like. There's a basis there's a structure, there is knowledge about products, people, and so on. And it should be better linked than just residing in different data silos and content repositories, nicely separated from the other repositories. That doesn't make sense. So what we need is an infrastructure where we can finally link all the information together, structure it in a way that it can be reused quickly, that it can be consumed by machines, by people, by other applications, and so on and so forth. So all the content and knowledge is locked up in structures, in schemas, in semantics, which are implicit, not explicit, not standardized. This is exactly what I'd like to talk about in the next 20 minutes or so. And why is that so important? What is the goal of all that? Well, actually, what we like to have in place are machines or systems which can give answers to questions. It's not just give me a document, I give you a term. This is no longer the standard. We want to have machines which give answers. You have a question, you get an answer. And all that builds the basis for what I exactly said before. If you want to make better decisions, if you want to deliver higher customer satisfaction, when you want to provide systems which help to discover knowledge, you need systems which can make use of all those facts, which are nicely somehow embedded in your databases, that you can find a lot of facts around your business object, potentially in each of your content repositories and spreadsheets, all that. But the problem is they're not really linked to each other. They're not structured in a way that you could use that information as the basis to ask questions and get answers in return. Like, is there a software company based in Austria that is specialized in graph-based text mining? I'm sure the data would be there in most cases to all the questions your employees, your experts, your partners, your customers have, but the data is not structured and linked in a way that a machine could deliver the right answer. So this is the goal, and let's take a look how we could get there. We have a couple of challenges ahead of us. Actually, 7 challenges at least I'd like to discuss in this presentation, that we can start to link all the information and put them together into one single structure called the enterprise knowledge graph. So this is a typical scenario, lots of different data sets, spreadsheets, databases, semi-structured content, maybe some XML based documents, completely unstructured text. All that is a typical scenario in our corporations. Maybe also some ways to classify and categorize stuff, taxonomies, all that. You can find it everywhere. And what has to be done in the next step is to find a way to bring those different content nuggets all together into one structure. Here are the challenges. Let's take a look at how we can address them. So the first one is about synonyms. Simply spoken, too many words, too many terms for the same thing. Machines cannot understand what we mean by several things because it's not clear to them. They don't have the context. As a human being, of course, we always can stitch together all the facts being found in different repositories, but machines need to have a more explicit data model to understand what's really meant. So, and this is done by introducing things instead of just using strings. And anything in our company could be any kind of business object, any instance of a business object should be addressable by a so-called uniform resource identifier, a URI. So here's an example. That's the URI of something called the Semantic Web Company, or also as a synonym, SWC. So this is, by the way, the URI in Wikidata, where you can find facts around the Semantic Web Company. Wikidata is a huge knowledge graph, which was developed by Google and community around it. And this is the center of Google's knowledge graph. Google is using a huge knowledge graph to index all the information being found on the World Wide Web. And this is kind of the blueprint we're talking here about also. So of course, the Google Knowledge Graph won't help you at all in your business because it's very specific. What you're talking about, your knowledge domain is a very specific one, but still we can make use of the same standards, the same structure, the same ideas, and we can also enrich our local knowledge graphs with knowledge graphs from other sources like Wikidata. I will come to that point in a second. Let's take a look first at the basics. So here, this is a URI representing a certain thing, which has those two names. And here's a triple, which connects two things to each other, which is SWC and Vienna. And the relation in between is located in. That means it's a triple consisting of a subject, a predicate, and an object. And if you put together thousands or probably even millions of such triples, you will end up with a huge knowledge graph, which is highly structured, which is consistent, which has explicit semantics. And with this knowledge graph, you can start to build a lot of intelligent and smart applications on top. And there's no need to just throw away all the data you have already in your corporation. The beautiful thing is you can use it and transform or translate it into those standards I mentioned before, into the semantic web standards. And most of it you can do even automatically. Well, this is the structure I mentioned before. This is a triple, and this can be used to do entity extraction from any given information. So you do not, you don't need to transform all your content into triples. It's not possible. We all know that. But you can run an entity extraction service on top, a concept tagger. Concept-based tagging is extracting things, not just strings. You see that here. So this is the thing which has been extracted from this text in English. And the same happened here from a German-speaking text. And again, it's all linked back to this single entity, to this certain business object, this thing with that URI. That's consistent, that's clean, that's clear, and that's the way to run text mining in essence when you want to structure and link your content. We can take a quick look at a little demonstrator, which you can find online with some other demo applications from our website. So let's take here some text into this box. Could be an editor in your CMS, for instance. I take a journal abstract, and you can choose from here from a couple of named entity recognition services, which are based on machine learning. And you will see in a second the difference between those entities extracted via machine learning. So those are terms, they are not things, they are strings. And here we have extracted things. So those are really, they have a URI, you see on the bottom left. And you can even go there. If you look at this one, it's taken from MESH, the medical subject headings. It's a thing, and it provides you with a lot of context information. And that's beautiful because now no longer you just extract terms, you really extract things with relations being embedded in a large knowledge graph. And that will later on build the basis to you to build question answer machines, recommender services, semantic search, and all that. There's a third example of a more statistical based approach to do term extraction. And here is another one, which also exposes the difference between classifying whole documents in contrast to just, extracting a lot of entities and concepts from a given text. Document classification, of course, is typically one of the first steps in a text mining pipeline. Those classifiers are mainly based on machine learning algorithms. You can train them. And again, a knowledge graph will help you to make those classifiers very precise. Well, let's get back to the presentation. I would also briefly talk about this virtual circle, which is running in the background. So this knowledge graph is not only manual work. Of course, there is a knowledge engineer involved. It's the human in the loop design principle, which typically builds the basis for that work. There's a subject matter expert working together with knowledge engineers, helping to shape the core components of the knowledge graph. But later on, a lot of parts of the knowledge graph and even of the core elements, the taxonomies and ontologies, can be partly generated semi-automatically. That's done through a continuous analysis of incoming new text and content. The data which is derived from that is already highly structured. It's kind of a subgraph, a little graph representing a given document, and that can build the basis to further extend on the existing taxonomies, which then in return will deliver even better results for the entity extraction and classification services. So this is a virtual circle which keeps the wheel going when enrolling enterprise knowledge graph. So let's take a look at the second challenge, which is about ambiguity. Ambiguous terms like here in that example, SWC can mean not only semantic web company in the context of software, of being a visionary named by Gartner. No, it can also mean it's a human rights organization, which is the Simon Wiesenthal Center in Los Angeles. But of course, as a human, well, you will figure out quickly, this is the software company, this is the NGO. As a machine, you need context to understand that. So if you want to extract it precisely and understand what the text is about, what SWC really means, you need context, and that's provided by the knowledge graph. So knowledge graphs are important for highly precise text mining. And then the third challenge is, if you want to build a question answering machine, you need a lot of background knowledge. Typically, it's like our human brains. If you read a news article, of course you understand the text much better because you have a lot of background knowledge. You know about the geographical entities found in the document, the people, the organizations. All that is typically what you can link to some other knowledge you have already generated from other occasions. Machines typically don't have that. So they just get the data per repository. So there's one repository which deals with a certain specific, let's say, sub-component of the bigger domain. And this can be used for instance, to train a machine learning algorithm. But there's nothing else typically available. And this is a pity because it's actually even available for free sometimes. GeoNames is a great database with knowledge about geographical entities. So for instance, you see here, if you link your local graph with GeoNames, you get quickly facts and triples around, for instance, Austria that's where Vienna is based, the population size. Or when we talk about SWC again, our partner RWS is, for instance, you can find a lookup on PermID, which is a huge knowledge graph used by a financial services industry. And here you find facts like Richard Thompson is the CEO of RWS. Great. So you can enrich your local knowledge repository with external data. You can use standard thesauri, standard taxonomies like we've just seen before, like MASH, like the standard thesaurus for economics, to enrich, to classify your business objects. And when others are doing the same thing, you can start to link it with data from your suppliers, from your vendors, from your customers, and so on. So this is great because it's all based on standards. That's why you can do that so easily. And then, of course, the multilinguality, that's a big challenge. We all know that. The simple case is you just have names in different languages, so the language tags, sorry. Like, for instance, in English, Vienna, in German, Wien, that's a simple case. So you can easily model that in the data modeling language provided by W3C, the Semantic Web Standards. Foresee this multilinguality, like SCOS, for instance, the Simple Knowledge Organization System, which is part of the Semantic Web Standards. You can use any language tag and introduce names for your business objects in different languages. But sometimes it's not as easy as it looks. For instance, this example shows you there's let's assume a concept called quality. But quality doesn't mean the same thing in Japanese and in Korean, even if it's the same label. Yeah. So it's just contextualized differently. There's a different connotation of quality in Japanese, which typically goes hand in hand with perfection. And in Korean, it's rather innovation. So even that can be modeled with COS. And later on, obviously, you can benefit from such knowledge graphs in several occasions. And then we have this huge problem of having all these different data models, different schemas. Each spreadsheet has its own semantics. Each relational database follows a certain schema, which is probably invented by a data engineer. It's not necessarily about the business logics. It's not like the business, let's say, users would probably express it necessarily. And by that, all the facts and knowledge are actually somehow deeply hidden away or buried in some implicit data models. So this is the problem. We need a way to bring that to the surface, to make a digital twin available of our documents, of our data sets, that we can start to link those to each other. And this is the challenge, probably the biggest of all of those, where the Semantic Web Standards can really help with. The knowledge graph is a kind of a universal interface between all the different data you have available, the heterogeneous repository landscape on the one side, and on the other side, the end users, the business users, which have a certain information need. A search intent can be better interpreted when having a semantic layer between the data and the business users. And this is exactly what a knowledge graph will help you with. And then, as a last point I'd like to bring up, which is also quite logical for humans, we all know, if it's just an example of inferencing. So inferencing is a mechanism where you can infer new facts from given facts. And this is something we do constantly. Yeah, our brains work like that. We know that when there is a legal entity located in a city, and we know, well, the city is part of a country, we know in return the city, of course, then and the country is the container of the city, that the legal entity must be in that country as well. But in a regular database, like a relational database, typically this is not clear. So this can only be provided quite quickly by using graph databases. So graph databases have this kind of mechanism typically built in. Also, the Sparkle query language is something which provides such mechanisms out of the box. And this is important, as you can imagine, when building out recommender systems or Q&A engines. So this is an example of a recommender system you can try out online. It's a demo centered around HR processes. And here we have not only this inference mechanism, you can also find search engine, semantic search, recommender engines, and all that. But the inferencing mechanism built in here is when a certain person, like in that case, for instance, Beverly Neal, if it's of course not a real company and not real persons, but if that person has a CV which talks about a certain occupation Beverly has had before, then we can infer, well, then certain skills must be relevant to her. So we can assume that this open position is interesting to Beverly. So this is a kind of inferencing mechanism each recruiter would do automatically, but the machine typically cannot do that. So you need a knowledge graph running in the background to come up with really good matchmaking algorithms and recommender services. So let's get back to the entry point of this presentation. We want machines which give answers to questions. I hope I was able to show you if we cope with those challenges, then we have a much better probability or higher probability to be able to automatically link all those different data sources together based on entities, based on business objects, on things. And when providing a knowledge graph as a foundational structure to our engines, we can build a question answering machine. This is something you can also try out live and online if you like. Go to our website, please, poolparty.biz, and find the question answering demo example in our demo application gallery. It's built upon a knowledge graph, which was initially generated out of unstructured data, for instance, CVs, some semi-structured data, like, for instance, an employee database and all that. So this is the way it works. That's how question answering machines can be built quite nicely on top of knowledge graphs. So those are some other, let's say, big points I'd like to use at the end of my presentation. Knowledge work based on structured and linked data and content means we get semantic search at our hands, better text mining, recommender systems which push data and information to our desktops. We no longer have to look around. The systems are aware of our situation, they are context aware, and the content and knowledge hubs will help us to save time, to see business objects in a 360-degree view, so we can look at the things in a holistic way. Enterprise search, deep text analytics, content hubs. So those are the typical applications. You can all try them out on your own. Please go ahead and take a look at it. They are all live on the web. Last but not least, I'd like to mention the Knowledge Graph Cookbook. It's free, available. There's also a Kindle edition. It's written for practitioners, lots of examples, lots of use cases, how to make use of knowledge graphs. I hope I was able to give you a nice introduction to this fascinating topic, knowledge graphs. You see, I'm quite passionate about it. And well, I'd love to keep on talking with you, and maybe there will be a good moment soon where we can get in contact and talk about this very interesting topic.